Welcome to today's webinar, everyone. We're going to be talking about overlays and widenings, a super common project type in RoadEng, but one that we never seem to talk about in our webinar space. So that's our plan for today. If you don't know me, I'm Erin. I'm one of the resident webinar hosts here at Softree. And yeah, I have the pleasure of hosting this super fast 30-minute workflow webinar. As I said, we're going to be talking about overlays and widenings. And here's a look at the typical workflow that we're going to cover today. So to start, we are going to be using both LiDAR and conventional survey data. And we're going to spend a little bit more time in the terrain module just because we're going to use both. And we're going to show you how to combine them and merge them. So our first step in our workflow is we're going to model that topo data, both the LiDAR as well as the conventional survey data. Then we're going to merge the surfaces together. If you're working with one type of data, you don't need to worry about this step. From there, we're going to create a new road design that uses the surveyed center line as the alignment, and we're going to do that over in our location module. We'll create a cross-section template that includes, first off, a portion that's dedicated to account for the milling of the existing surface, and that portion is going to have a reference feature that ties it. So it dynamically adjusts to match the surveyed edge of road. So that's the milling portion. And then we're going to also have a widening portion in our template, and that's going to account for widening the existing road with a notch cut to rebuild the shoulder structure. So the template's going to be, sort of two parts in it that we're going to talk about and look at. We'll apply it to the design, and then from there, we can get our volumes, check them, and create some really quick construction documentation to take the project further. So that's our workflow. We're going to spend the next 28 minutes now that I've taken up to going through what that looks like in the software. As I pass the screen over to my colleague Matt, this is just a reminder, if you have questions, open up that Q&A section of the GoToWebinar panel. You can type them in. We'd love to answer them and tackle them live, and we'll do that at the end of the webinar. And with that, Matt.
Cool. Thanks, Erin.
I can see your screen, I can hear you, so it's
awesome.
Over to you.
In business. All right, I'm going to run through, as introduced, a quick overlay and widening job. There's a bunch of different ways we can handle different aspects of this. So we're going to largely choose one approach and add in a few tips where they're might be useful. So I'm going to start out in terrain. And so in terrain, we're going to use the software to build our terrain model. And in this case, we're going to model both our conventional survey data and LiDAR data separately to start. So I'm going to just work first by bringing in my conventional survey. So I've got a CSV with that. I've got an IOP set up, so it's nice and easy. I don't have to worry about playing connect the dots unless I miscoded something. So all this is, I've got it, so my surveyed center line's being brought in as a red dashed line, and say my ground shots are being brought in as just a point and a cross. So we'll hit OK, and as expected, we've got that line work in there. And here I'm going to start by just modeling it by clicking the buttons here. But I'm going to talk about kind of an extra step that's nice to consider when you're merging two data sets together. So with this, I see my surveyed center line, my edge of road, but I've got these kind of long triangulations here that I don't necessarily want to include. So rather than controlling how far out my survey is interpolated here, based off maximum side length, I'm going to use a tin boundary feature. So all I'm going to do here is I'm going to take what I want my edge of my tin to be. I'm going to just play connect the dots for around these corners. I'm going to join these two features together. I'm going to do the same at the other end. I'm just connecting the dots here on the end just to make sure I don't have any lines crossing over other lines that might lead to crossing break lines. So we've got that, and we're going to change this feature to be a tin boundary feature. We'll hit apply. Now, when we remodel this tin, we'll see that we don't get these long, unfavorable triangle edges, and it just adheres right to the edge feature that we have set up. So that's my conventional survey surface. I'm going to hit File, Save As, and I'll give it an arbitrary name, and then I'm going to deal with my LiDAR data. And just to have it, I'm going to use that center line. So this is one of the things that there's kind of two ways to do it. If you're combining your LiDAR data and conventional survey data, you can just insert the two into the same file. Or you can do a merge. So the merge is we're going to take out all the survey data in the LiDAR data set that overlaps with our conventional survey data set. This will make a bit more sense once we bring it in and actually do it. So right now I'm bringing in my LiDAR tiles. So I've got 4 tiles here. I could thin it on import. I'm probably going to thin it afterwards. But with that, we've got millions and millions of points. The computer's sorting through as it brings it in. And so it's not instantaneous. We'll have to wait a moment while those points get read in. It shouldn't be too much longer here. And our last tile is getting brought in there. And there we are. So I'm going to just click off to the side. Now here we've got 5 million points in there. Reasonable amount to model. I'm going to reduce that though. So I'm going to just, I'll take that surveyed center line that I copied from the one file, and I'm going to tell the software, well, I only want my LiDAR data within, say, 300 meters of that. I'm going to, well, we want to remove all the points outside of our corridor, which is this CL feature. We'll set our corridor width. We'll hit OK. And now instead of having 5 million points, we've got 1 million. And that's what the point cloud looks like where we have our remaining extents. Now, if we want to, we can model this. I'm not going to worry about contours here. But there's our LiDAR surface. And here's where, if I'm marrying the two surfaces together, I'm going to use the merge function. I'll go up here, I'll click Browse. I'm going to grab that conventional survey that we've just brought in. I'll click Open. Here I can change the stitching offset if I'd like, and I'd hit OK. And well, it would take a moment and it would think and sort through and take out all the LiDAR data within the road and place that survey data that we have in the other file. And this takes a minute or so. And just to save you guys watching my screen think, I've already done it. And so here we've got our LiDAR data outside of the road prism and our survey data within it. And then here's that stitching offset, which I mentioned in there. We're going to take that, we're going to just turn it into a surface. We'll create some contours at the same time. And now we've got a merged surface that uses both our conventional survey data where we have it, but outside of that conventionally surveyed footprint, we've got our lie data. And again, as introduced, you don't have to do it with one or the other, but it seems like a pretty common way for folks to work with the data. So I'm going to save. And we're going to switch gears to location. All right, so here I'm going to click New File. I'm going to browse that terrain file that I've just saved. And here we've got that surveyed center line. And in this case, we are going to use it as our alignment. So we're going to set that up there. And we'll click Done. Now there's, again, one of those things that there's multiple ways that folks will decide to approach the problem. One strategy is, well, I want to model all my curves and make sure what I have here is up to snuff. And in which case, if we were going to do that, we could. So here we'd say, well, instead of just using that polyline, we could use our polyline to alignment tool. And with this, we have to give it a little bit of a tolerance. So we'd say, well, fewest curves as possible within 1 meter of the original feature. We can hit OK. And it's going to take that and it's going to, well, reduce that down to, just as I said, fewest curves as possible within that tolerance. And we could check to make sure our curves match our design speed. The other strategy, and I'm going to hit undo here, is, well, we want to use exactly that surveyed centerline alignment. We don't want to change anything. We just want to make the road, well, repave it and make it a bit wider. So if we want to go that route, we'll just use that surveyed line as we have it. But we probably notice pretty quick, well, we don't want to actually rebuild our whole prism. We don't want to excavate out the existing pavement structure. We just want to do that shave and pave. And it's pretty apparent right off the bat that our cross-section, our default cross-section, doesn't do what we'd like, but we can make it do what we'd like really quickly here. So we're going to go up to our template editor. Here we can see we've got 3 default templates. None of these are kind of that shave and pave and widening that we're looking for. So we're going to bring in the components from our e-library that we might want to use. And to start, I'm going to use the rural road as a starting point. And I don't want that roadway component, so I'm going to get rid of those. And I am going to go to my overlay and widenings folder. Now I want to use my widening 2, so mill overlay. We're going to paste it in here. We're going to configure one side and then we're going to configure the other. So we'll double click that. Now here's where we're going to use reference features. So rather than just treating that surveyed road edge as or edge of pavement as a fixed offset, we can set it up to reference the actual surveyed feature, and then it's going to dynamically move in and out as needed. And we'll set a reasonable default value here too. So we're going to go in here. We are going to say, well, this reference feature comes from our topo surface, or topo terrain file. And we'll scroll down and we've got a couple EP, so EP just surveyed as edge of pavement features that we're going to use. We'll click the drop down, and now as we move around, that edge of pavement stays where it's surveyed. Now these other options, well, I'm going to set my new road width to be 4.5 meters. I'm going to add a 2-meter shoulder on the outside of that. We'll set our ACP thickness. We'll set that as 0.2, and we'll do our sub base as 0.6. So these template components, they're really just a fillable form, and we can see the changes that we're making as we make them. I'll change that fill slope to 4%. I'm going to set my shoulder slope to be steeper than the defaults, and I don't want my super elevation being applied to the shoulder. So we've got that. We don't have to click all those buttons and punch in all those numbers again for the other side. We just copy, paste as right. And here, if we want this to match up with our existing crossfall, we can set that, and now it's going to just better contour around the existing road rather than changing what's there. My ditch, I'm going to change this. And my slopes, let's go with a 3-to-1 cut slope and 35% fill slope. We'll give this a name. We'll hit OK. So nothing changes. We have to go up here. We click Assign by Range, and we assign that new template that we've just created. And if we want to apply it to the whole road, we can. So we'll go dot, dot to dot, dot. We'll hit OK. And there we are. So we can see what we're dealing with. Yeah, and then if we want to, we can cruise around. So say like here, well, we're probably not going to be able to reuse that old pipe. Our footprint's quite a bit wider. So we can go in here and click Add. Now that is extending on through my topo, so I want to match the crossfall of my existing ground rather than using a 5% drop. We'll change our size to whatever we'd like. And we can tweak our skew if we'd like here too. And if we're happy with what we've created, we can go over to our multi-plot, and we could build this out from scratch if we'd like. So we could add in our various subviews. In this case, I'm not going to. I'm going to say, well, I want to use a size B sheet. I'll just connect to the E library. We've got something that is usable there, at least as a starting point. We've got our plan over profile, and we'll bring in our section view. Oh, and here we can see we've got a little bit of a faux pas right at our start station, and we will just mention what's going on there. And all this is that my reference feature isn't existing there. So I've got a couple options for what I do. I could well, I could change my template so it's not set to a reference feature, or I could just move in my start of my road a hair to match what I'd like. So it lines up with that surveyed feature that we'd like to reference. And there we are. And here, if we want to change that to be our 0 station, we can make that change, and now our start of a road is at 0 the way we'd like it. So that is a really quick and simple run through on the shave and pave where we're widening the road and well, using the existing alignment as our design alignment. One thing that I will just kind of mention that comes up every now and again. For this, my volumes are split out. So for this, if I go in here, I can see I've got my subgrade being tracked as kind of the portion of my cut outside of the existing prism. And then I've got SRF1 as our fill. I've got SRF4 as my, sub base versus base versus ACP is 3. So when we look at our data table, we can see those various items being called out. And then I've got a cut area for 2. Now cut area is going to be my mill in this case. So if we want to look at all those various volumes that we're dealing with, we can in our data table, but in this case, my data table doesn't match up with what I'd like to see. So we can come in here, we can change this. Now I'm going to get rid of a few of these that aren't really interesting for what I have going on. But I want to look at surface 2, surface 3, surface 4. Actually, in this surface 2 is my shave and pave, so I'm really, or the shave portion of my shave and pave. So I'm really interested in the cut volume there, and we'll go with that. So now we can see the quantities for those different materials. The spacing for how those are getting reported is controlled by my report point spacing, and I've just got mine set at 250. And that's that. And then if I want to take it a step further, and instead of just referring to those as SRF1, 2, 3, 4, etc., I can change that here too. So subgrade I'll leave as subgrade. Surface 1, of course, I forget what I said there. So surface 1 is going to be my base. Or sub base. Surface 2. Surface 3 is ACP. And surface 4, I believe, is just my base. So we'll hit OK. And there we are. We've got those different materials called out. And then the last kind of part here, of course, we want to build it. We're probably going to want to stake to it. So file, save as, and we can export our data as well, any number of digital formats, but the common ones would be land XML, DXF, or CSV, or ASCII, I guess. So with that, we can open it up for a few questions.
Awesome. I'm just going to steal the screen while we let people have a chance to enter some questions into the chat, and we'll get to the ones that are there already. But just letting everyone know that we have, it's literally being announced within the next 5-10 minutes, a three-part, well, not three-part, but one webinar, but we're doing it actually a different time zone. So for those of you who are joining us, for example, in New Zealand at the crack of dawn, or over in Europe or the Middle East really, really late at night, we're putting on some webinars that hopefully have some better time zone overlap for you, talking through a workflow using Path Explorer. So most of the emails, I believe, for this are coming out here in the next 5 minutes. But this is happening next week, and you can check it out and register for them up at softry.com/webinars. With that, Matt, I will let you steal the screen back as we tackle some questions.
All
So
right.
your first question is, can we have separate quantities for each side?
Yeah, so if we wanted to do that, we could. So like if we wanted this base material to be tracked separately from the other base material, we could. We could go in here and we could, well, at the component level, switch around what layers are what. So actually, we probably wouldn't do it with subgrade, but if we wanted to change that, we could change it to another layer. Yeah.
Okay. The next question is, can you set constraints for minimum fill based on the chainages?
You can. But so this workflow that I ran through, I was kind of going with the conventional side of things. Or actually, maybe I'm misunderstanding the question. Yeah, I'll try answering it 2 different ways, and hopefully one of them answers it. If we were like optimizing this, I guess if it's fill at the center line alignment, if we were considering realigning this and we wanted to, well, not just have this really conventional shave and pave, if we wanted to lift our road in certain locations, we could optimize it. And in that case, we would be using the optimizer where we can set minimum cut, minimum fill parameters. Yeah, so if that answers your question, great. The other way would be if you're referring more to how deep your kind of notches with the sub-base material getting added in, we absolutely could. We can tackle that a few different ways. So one would be we can make an entirely different template, and we could have a different value for the materials making up that notch. 2 would be we could override the existing, so we could go in here and say, well, actually I need to check my feature name. So I've got my sub-base thickness. So if I wanted to override my sub-base thickness and didn't want to create an all new template, well, we could do that in overlays or overrides. Scroll down to sub-base thickness on the left, and we could apply a different value for a certain range if we'd like. So yeah, this kind of throw it in. We'll go, I don't know, look. And so here I've just overridden that depth, yeah, for a specific side. And there's other ways we could do that by modifying the template and having it controlled by a feature as well if we wanted to. But yeah, hopefully,
Awesome.
hopefully that answers your question.
Great, Matt. Let's do one more, and then yeah, we promised this one was half an hour, so we'll wrap up relatively close to on time. The last question we're going to tackle live: can this template be used without widening, but rather having a shoulder milling different from the lane milling?
This component, no, but there might be a component that has that in there, and if not, we could certainly set one up that does that. Yeah. So that's yeah, and it would just be a matter of going through the list and kind of reading the different parameters for what's what. But yeah.
Awesome. Okay, guys, 11:30, we're on time. I feel like it's a record and we should definitely just cut the questions there. There are a few remaining in the chat. I just sent some notes back, but we'll follow up with those folks directly. And have a wonderful rest of your day. Thanks for being here, checking out widening and overlays, our first time doing this webinar type, I think ever. So thank you and have a wonderful rest of your day, everybody.
Thanks, everyone.